Hi everyone, I'm Yogadharani, working as Assistant Professor at Department of Computer Science and Engineering at SNS College of Engineering. As in previous video, we saw about asymptotic notation, that is a big O notation. In this video, today we are going to see about what is a big omega notation in DAA subject. So, big omega notation, definition of big omega is function f of n is said to be big omega of g of n. Denoted f of n belongs to big omega of g of n if f of n is bounded below by some positive constant multiple of g of n for all large n. That is, if there exists some positive constant c and some non-negative integer n naught such that f of n greater than equal to c into g of n for all n greater than equal to n naught. So, for your reference, kindly see the graph. Here n turns here x-axis marked as n number of operations and y-axis is referred as t, a number of times it executed. So here the function f of n and c into g of n is all in big omega. G of n is always the lower bound of the f of n function. That is a upper bound. Upper f of n function is always the upper bound of the f of n, and that intermediate point between f of n, g of n marked as n naught. So the general term is f of n is equal to omega of g of n for all n greater than equal to n naught. Examples, we'll see the example. See, big omega notation, the main points, that is key points of big omega notations are, it mainly represents lower bound of algorithm running time. So by big omega notation, we can calculate minimum amount of time that an algorithm requires for its execution. So it is big omega is mainly used for best case time complexity. As I already told the definition of a big omega notation, let f of n into g of n by two non-negative functions, then f of n is equal to big omega of g of n. If there exist two positive constants c, n naught such that f of n greater than equal to c into g of n for all n greater than g of n. So examples as follows. See here, this is the example for big omega notation. The general term of big omega notations are f of n is greater than equal to c into g of n for all n greater than equal to 0. Example, let us assume f of n is equal to 3n plus 2 and g of n is equal to n. We going to apply f of n and g of n in the general term of big omega notation. So apply in equation 1. So in 3n plus 2 is greater than equal to c into g of n is n. In this equation, we consider c is equal to 1, n naught is equal to 1 because n greater than equal to n naught. So apply n is equal to 1 and c is equal to 1 in the equation. Here 3 into 1 plus 2 greater than equal to c into 1. So 3 into 1, 3 plus 2, 5 greater than equal to 1 into 1, 1. So hence proved. And also we are going to increment the value for n. Now n naught is equal to 2. Apply n is equal to 2 in the equation of big omega notation. So 3 into 2 plus 2 greater than equal to c value is 1. 1 into n value is 2. So 3 into 2 is 6 plus 2 greater than equal to 1 into 2, 2. So 6 plus 2, 8 greater than equal to 2. So we hence proved f of n is always greater than equal to big omega of g of n for all n greater than equal to n naught. So in this video we saw about what is a big omega notation, its definition, its graph and example for a big omega notation. In next video I'm going to explain about what is a theta notation and why and where should be used there. Thank you.